Hi, this video will be on AC and KVL and how they are used to better understand electrical systems. Alternating current, also known as AC, is more common than DC because it is used for many household applications such as lighting and for appliances. As AC is constantly changing polarity, it is most often represented as a sine wave. A common way that the voltage is measured is in the peak-to-peak value. The time it takes for the sine wave to make a full rotation is called the period. The period is made up of 360 degrees and can be used to find the frequency, as the frequency is the reciprocal of the period. KVL stands for Kirchhoff's voltage law, which is Kirchhoff's second law and is based on the conservation of energy. It states that the algebraic sum of all the voltages around any closed loop in a circuit is equal to zero, which in other words means the voltage drop within a closed loop of a circuit will be equal to the power input. This can be represented in the following equation. As it is based on the law of conservation of energy, KVL is applicable to both AC and DC circuits. While using KVL in AC circuits, the period of the waveform needs to be considered in the calculations. As voltage in AC is represented by a complex number, the voltage needs to be represented in either rectangular or polar form. Complex numbers have both a real and an imaginary part. The imaginary part comes from the phasor angle. These numbers can be represented as shown. To complete addition or subtraction with complex numbers, as is needed for KVL, the values must be in rectangular form. Adding voltages in rectangular form involves the addition of the imaginary parts and the addition of the real parts respectively. Subtracting rectangular numbers follows the same concept. Here is an example with a voltage supply of 60 volts at 45 degrees and two elements, one with a voltage of 20 volts at negative 45 degrees and one with an unknown voltage. To solve this problem, the first step is to convert the values into rectangular form. From here we can apply KVL and sub the values in. Once we have done that, we can perform the subtraction by subtracting the real component of V2 from the real component of the input and subtracting the imaginary component of V2 from the imaginary component of the input. And once we have converted back to the polar form, we have our answer. Thanks for listening. Hi, this video will be on AC and KVL and how they are used to better understand electrical